cookies dangerous? Okay. And actually, I have a whole bag of Chips Ahoy here with me that I don't think I should be crunching in your ear. All right. But we have chocolate chips. So we read an article that said cookies are dangerous and we should get rid of them immediately. And I'm like, what sacrilege? Who's publishing that? But the more research I did, the more terrible things I found out about cookies. And this is what happens when you do research. You find out all kinds of strange things that are going on. So who knew that chocolate chip and sugar cookies could be that harmful? Now, yes, we know about sugar and diabetes and everything else. I actually have lost, and about 4 or 5 years ago, lost about 125 pounds. So I'm a lot thinner now and nice little size 10, where I used to be a size 22. But here's some statistics we've dug up and we'll convince you that you should never eat another cookie in your life, okay? So cookies are made from a substance called dough. And I mean, I know a lot of us have eaten cookie dough, right? So it's been proven that as little as 1 pound of dough can be used to suffocate a mouse. The average American eats more cookies than that in 1 month. Okay. If I really wanted to, I could probably polish this off in 2 nights. Easily, okay? And this is my bag. This is not daughter's bag, okay? This is mom's bag. Primitive tribal societies that have no cookies exhibit a low occurrence of cancer, Alzheimer's, Parkinson's disease, and osteoporosis. Cookies are often a gateway food that leads to using harder items such as ice cream, brownies, or even cake. Newborn babies can choke on cookies. In the 18th century, when virtually all cookies were baked in the home, the average life expectancy was less than 50 years. Infant mortality rates were unacceptably high. Many women died of childbirth, and diseases such as typhoid, yellow fever, and influenza ravaged whole nations. Okay? So one thing about a standardized test is we get something called the bell curve, right? We expect to see like a normal curve, okay? Because most IQ tests are done up on that normal curve. All right, so these are all the people who scored below average. Does that statistic impress you? Not really, okay? Like the other half scored above average, right? So when I look at this group, this is the other half, and they scored above average. So I can actually dispel that myth, okay? Cookies are proven to be addictive. Okay, I will tell you, I have a real thing. Subjects given the choice of cookies or broccoli to eat for 10 days straight will always choose cookies. These statistics should not lead to the conclusion that cookies are bad for you. What's a good, okay, like pick one. Like I can say newborn babies can choke on cookies. Guess what? They can choke on broccoli too, right? They can choke on oatmeal. Newborn babies only have the ability to swallow liquid, and that's it. All right. So they're going to choke on anything. I can totally dispel this myth right here. Okay. Yeah. I don't know if it's the cookie or if it's the content of the cookie. So once you get on that sugar thing, it's really hard to get off the sugar thing, right? So primitive tribes have no cookies, exhibit a low occurrence of cancer, Alzheimer's, Parkinson's, and osteoporosis. Why do they have a low occurrence of that? It's not that they don't have cookies, it's that they eat much healthier diets and they are not exposed to what the rest of us are exposed to out in society. Yeah, a pound of dough can suffocate a mouse, but then so can probably most. So there's all kinds of things in here that they sound kind of interesting, but there's not a cause and effect relationship between them. It's just coincidental, and that's it. So I can't really come back and say, this is true, okay? So if I want cause and effect, we're gonna cover this. I need to run an experiment, and I have to have a control group, and I have to have certain parameters in place, and I have to be able to measure it. Okay, I can't just look at the results, say this is what's going to happen. Okay, some of these, yes, cookies can be proven to be addictive. Well, yes, if you give me enough sugar, it's the sugar I'm addicted to. But that just goes to show you, we're going to debunk things like this. All right. When you do data science in terms of how you organize it and everything, that is not statistics. Data science is really about managing metadata than anything else. All right. Statistics is really about the analysis of that data. So if you've seen old-fashioned bottles of Coca-Cola in glass, what's the breaking strength of those bottles? Okay, those are objects. Then I might want to look at those. Maybe I want to look at how quickly shrimp are growing, a particular type of shrimp in salt water, depending upon the amount of food that I feed them. Those are objects. We don't call those individuals. The information that we organize, though, is done using variables. And variables are going to be different than the type of variables that you see in algebra. Now, yeah, we have a lot of, there's a lot of really good math in here about all that, but the variables can be qualitative as well as quantitative, okay? So individuals are objects described by a set of data. I kind of don't like that, but they can be people, they can be animals, they can be inanimate, okay? Variables are the characteristics of these objects that we're looking at. So they can take on different kinds of variables. So we can talk about categorical. That is your eye color, your hair color, your grade level in school, okay? Let's see what else we could do is categorical. The way you get to school in the morning. Do you take the subway? Do you ride with somebody else? Do you drive? Do you take a bus? Do you Uber in? I had to Uber last week because my car was in the shop, okay? That sort of thing. Or it can be quantitative. What time did you go to bed last night? How many hours did you sleep? All right. How much fluid have you drunk for the day? I'm thinking I'm working on like cup number 8. All right. This is my, I got the grandma cup. So, and I usually have, like you guys, the big bottle that I drag around with me all during the day. What I do is when I leave in the morning, I don't have liquid in it. I fill it up when I get to school, but I put ice in it and the ice stays in there all day, right? So, so categorical variables look at specific groups, okay? Those are things that we cannot measure. Quantitative take on numerical values, so we can do arithmetic operations. Like we can add them, we can average them, and then we can look at them in terms of discrete or continuous. Like your weight is continuous, okay? The amount of sleep that you get is continuous. So in order for me to be able to say I slept 7.5 hours last night, I had to have slept 7 hours to get to that, okay? All the previous times prior to me waking up, those were continuous, all right? Now, discrete is basically what I can count on my fingers. Okay, how many cavities do you have right now? Right? I can count those on my fingers. How many tests do you have going on this week? That's discrete. So if I can count it on my fingers, okay, whereas continuous is what I call measurable. So something, let's put a couple things in here. So quantitative, I could say discrete. Oh, how about the number of siblings that you have? For me, it would be, maybe I'd say, how many cats do you have, right? So the number of cats. Shoe size would be discrete. You go from an 8 to an 8.5 to a 9. Okay, so we could look at that. Temperature is, whoa, I sort of bounced here. So temperature is continuous, whether it's your own body temperature or it's the temperature in your classroom or the temperature outside. But that kind of thing is continuous because It is constantly adjusting and changing. Okay. Let's see. So anything related to time is continuous. So categorical, we could say gender, right? We could say eye color. Let's see what else we have. T-shirt size. So we can go from the extra small up to like a 3X, right? Okay. So we can just say extra small to extra, extra, extra large. I actually tutored the football team, a couple of football team players, on Tuesdays and Wednesday afternoons after school. And let me tell you, those guys could wear a 3X. They're pretty big. Okay. They're really sweet, but they're really big guys. All right. Your grade. So like your letter grade, whether you're liberal, middle of the road, conservative, those are still categorical. All right. Now, I'm going to throw one more at you. Just because something is a number doesn't automatically make it quantitative. Can you think of a number that might be categorical? Well, okay, there is a thing you can actually do categorical, would be like the millennials, right? Think of that. See, all the people. So what do we got? Gen Z, Gen X, millennials, everything that's in there. Those are categorical because we're lumping things in. So just because you're a certain age doesn't mean that it's quantitative. How about zip code? Okay, the mailing code. So in the US, zip codes are 5-digit numbers. Okay. And so based on that zip code, that's a geographical region that's in there. And that's categorical. Okay. So we look at those. And I know they're different for different parts of the world. So when you've got primes or constants, when you've got primes, what's another one? Perfect squares and not perfect squares. Okay. That kind of thing you can add. So when you talk about organizing integers, just those organizations of like, here's Z, here's all reals, those are categories, right? That's how we identify them. So the counting numbers versus the whole numbers. One's got 0 and one doesn't. Okay. So lots of things. Well, we're going to look more along the lines of the ones that we have here. Okay. So discrete ones, generally decimals are not an appropriate way to record the data. Okay. Trying to think if there would be any that I did. So decimals are usually appropriate for stuff that we have to measure. Okay. It's interesting, even though most of my cooking is done in terms of like cups or half cups or teaspoons or tablespoons, I'm now getting to the point where it's more and more I want to do things in grams because those are the recipes that I find. So that's kind of interesting. Age is always the one that we get hung up on. So is it continuous or is it discrete? It can be measured with a decimal. Your age is constantly changing, right? You age as long as you're going. But we count by the number of birthdays that we celebrated. Okay. So we tend to make that more discrete than continuous. Okay. But in terms of our age, typically it's always continuous in here. So yeah, I'm not going to say that, on this many years, let me think. So when we look at the first 10 US presidents, their political party and their state of birth, lots and lots of presidents are born in Virginia and even now in Ohio. Those are probably, I think, the two most, Virginia, Ohio, and I want to say New York, okay, are probably the most popular. But then we look at the parties. So the Federalist Party doesn't exist anymore. Neither does the Democratic Republican. Okay. Neither does the Whig for that matter. Okay. So we can look at this and say, can I organize this? So I have 10 people here going from Washington to Tyler. So I can just do counts. And so filling this in, I can say, well, I have 2 out of the 10. So relative count is that this represents 20%. And for Democrat, Republican, I have 4. So that represents 40%. Okay. And then for Democrats, let me see, what do we have? Just 2 and 2 wigs. Now, when we do this, we want to make sure that we get the full 10 here and we get the full 100% at the bottom as well. The other way we can make a table is we can call it frequency, and that's typically what we're going to work with is frequency as a word. So if we looked at how many times does Virginia show up in here, in these first 10, there's 6. So relative frequency says that this is 60%, okay? And then I come in and have New York, and I only have, this point, Martin Van Buren, so there's 1. He represents 10%, the first. And then we have South Carolina, which is also 1, Andrew Jackson. Okay. And then we have 2 that were born in Massachusetts. So that's 20%. Now, I'm still trying to find if I'm related to any of these guys. We did the family tree some years ago, and I found out that my dad was related to Barack Obama's mother. So we're like 10th cousins, okay, which is kind of interesting. But the thing I found that was even more interesting is that the first governor of the Massachusetts Bay Colony, who was the one that was overseeing the Salem witch trials, is like my 7th great grandfather. That was a real mind buzzer when I found that one out. Okay, did not want to do that. So I'm just like, wow. Every once in a while, I want to go read up on them a little bit. Now, so maybe we want to do 2 variables at a time. We want to look here at political. Okay, come here, highlighter. That's not. We're being sleepy. Okay, doesn't want to do it. I'm telling my pen died. Like, did I bring the other one down? No, maybe I just flipped it off. I have a tendency to do that. Just push my pen in and I flip it off. Okay, here we go. Political party. Okay. And then I want to look at state of birth through here. Okay. And so we'll do a 2-way table. We're also going to do this with like numerical. So when I fill it in, I have 1 Federalist from Virginia, and I have 1 Federalist from Massachusetts, so 2 total Federalists. And then the Democratic Republicans, there were 4 of those. So if you notice that the numbers that were here are going to come down to what we call the marginals, okay? So we finish doing things in the margins. So these are called the marginals. And so in Virginia, I had 6 here, 1 here, 1 here, and 2, and that everything sums to 10. So when I fill this in, I had 3 Democratic Republicans from Virginia, 0 Democrats, and 2 Whigs. That's the distribution of the 6. And New York is represented with just 1 person right here. This would be a lot more fun if I had like all the other guys, but there have been way too many changes in political parties. Probably what I'm trying to think was right after Lincoln that we had the last change. And then South Carolina, of course, just has 1 right here as well. And then Massachusetts has 1 Democratic Republican, and that's it. Okay, and that's a 2-way table. So this table, what I'm looking at here is, here's my totals through here. Okay, and I kind of break it up this way. So here are my totals, and I look at it like this. Okay, and there's my 2-way table. So my marginals are the what I basically think about as summing it up in the margin. And that way I can see that data from the 2 tables, and I can see everything organized to give me a better idea of the distribution of what this really looks like. So there I can see who were the most influential. Probably these guys right here. Okay. in terms of looking at things. So that was really was kind of interesting. So distributions is of a variable tells us what a variable takes and how often it takes these values. So in this case, I had 4 Democratic Republicans, and I could see that 75% of them came from Virginia, right? That's kind of the cool part about doing it. Now, so a two-way table is kind of fun to put together. And I get lots of stuff like that because I'm always having to do data on my students and saying, here's how they're doing, you know. Like I just gave a calculus test and gave it back today, and I'm like, oh, you know, out of my 12 students in calculus, 6 of them got an A on the test. You know, 6 of them got, I'm trying to think what was the lowest A. A 94 or higher. Okay, this is pretty good. All right, so then we can do bar graphs. So maybe I can just come in here. And so when there's a difference between a histogram and a bar graph. In a bar graph, they never touch. All right, so that's going to be kind of the big thing. And I always love this because I get to do, you know, I got to get rid of this green. Hold on, let's do the darker green. Okay, not that color, not that way. I like it to do my shapes. So this is how I get really nice graphs, okay? And so I'm going to look up here and I'm going to do frequency going up the side. And so I'm trying to scale things appropriately. That's about the only time I scale. I never scale anything in calculus. So then I'm going to come down here at the bottom and I'm going to say political party. Okay. And so the first one, let's see, we had 2 from the Federalist. So I'll put Federalist here. And then I had 4 from the Democratic Republicans. Two from the Democrats. And then 2 from the Whigs. Okay. Now, we are going to learn how to do a graph that represents like the widths change, okay, as we go through this. Here, what we do is we make equal widths, all right, but the bars cannot touch. And that's what everybody makes, you know, an issue with. And you must label, okay? So you must label both axes. You do not necessarily have to label the top of the graph, okay? Let's see, I'm trying to think what else. So usually we do a frequency or we'll do a relative frequency. So I'll do 1, 2, 3, 4 here. But if I wanted to do it in percent, you know, I would still have the same thing, 20, 30, 40% as I was going through. All right. And then I can usually answer some general questions from here. So of the first 10 presidents, what political party was the most affiliated with? And that's going to be the Democrat Republicans, right? Okay, that sounds like really, if you keep up with US politics at all right now, putting those 2 words together is just weird, okay? Which political party was the least affiliated? Well, you know, it's kind of an equal thing, okay? So it's balanced, so it's evenly shared. With the Federalist, the Dems, and the Whigs. Okay. Now, what are the individuals in here? So I'm really looking at the individuals that pop up in here are basically the first 10 US presidents, okay? So we're gonna come in here and say 10 US presidents. All right. And the variables in here are both categorical. So we have two categorical variables. We have state of birth. Okay. And we have political party, right? I couldn't believe it today. I was talking about something in class and Hamilton came up, and come to find out the class I was in, they had not seen Hamilton. And I'm like, how in the world have you not seen one of the biggest shows to come off of Broadway in the last 10 years? I am blown away. I did get to see Wicked 3 weeks ago. It was the Broadway show is touring in Durham, was touring. It's actually still there. And it was amazing. We went the opening weekend and I absolutely loved it. So it was really fun. Okay, we can use what we call pie graphs for categorical, but that's not covered on the AP exam. So you're really not ever going to see that. You won't know how, you don't have to know how to do those. Usually if I ever do them, I gather my data and I do it in like a Google form, because Google Forms will create pie graphs for you when you collect categorical data. So if I'm looking at, like, I'm having students complete a survey at school right now, and they have to give their grade level. So freshman, sophomore, junior, senior. And so it gives a pie graph to show that, okay? So we're also, so the ones I was talking about earlier where they have differing widths on them are going to be mosaic plots. And we're also going to look at segmented bar graphs because those have been very popular on the AP exam the last couple of years. So, and I think I forgot to say, but I'm an AP reader. So I've actually started being an AP reader in 2015, and I've been a reader every single year. The new teacher in my school is teaching stat this year. We got him accepted to be a reader. He's very excited by the opportunity. I said this would be awesome for him. I'm probably going to try in another year to see if I can switch to scoring AP calculus. But it's been really good because I trained now 2 teachers in the last 2 years to do stat. And I go in there and I say, okay, here's what you guys have to know before you take the exam. Here's what we're looking for. We literally, half your score is about how you communicate. It really and truly is. So that's kind of the interesting thing in there. Okay, that's the first set.